Section 4.4, Universal Gravitation. By now, we all know that the Earth is round, and if you have questions about whether it is, we need to have a much longer conversation. But the shape of the Earth, the reason that it's roundish and spherical, is entirely due to gravity. Gravity pulls everything towards the centers of objects, pulls everything in together. So as gravity collects all these different pieces that would become planets and stars and things like that, it's going to pull them into a ball. It's going to pull everything towards the center. And so that's why when you see large heavenly bodies like planets and stars, they're circles, they're spheres, they're circular. This is just one reason why the whole flat Earth thing doesn't even work, because gravity would make no sense in a world like that. There's also about 1,000 other reasons. We also know that the gravitational force can tell us something about what we see in the stars and in the universe. When you have massive planets or massive celestial objects near each other, past each other, the gravitational force can cause the planet or the orbit of a planet to wobble a little bit. Those wobbles are called perturbations. And basically, you can see how one planet would affect another. And perturbations like this is what allowed astronomers to discover Neptune. In the early 20th century, Uranus's orbit was perturbed a little bit, and it was thought that the only way that happens is the presence of another planet beyond Uranus that was about the same size, and astronomers were able to essentially predict exactly where Neptune was going to be, went out that night and found it right where they looked for it. So they used Newton's law of gravitation to predict where a planet would be, and then found it the day they predicted it. So gravity allows us to figure out a lot about what happens with the heavens and the stars, and we can use this to understand more about the rest of the universe. We use the same idea that we used to discover Neptune to find planets in other solar systems, to find find smaller objects in our solar system. So even though as time went along, Newton's ideas of gravity were advanced by Einstein, his laws are still useful when we try to understand how objects are influenced by other objects in space.